Hello, everyone. Thank you for joining the CAD Talk webinar entitled Five Simple Fixes to Your Bill of Material to Improve the Value of Your ERP. My name is Jeff Brickler, and I am the Solutions Architect at CAD Talk. I have been working at CAD Talk for over 6.5 years, and during that time, I've implemented customers all over the world with our software CAD Talk ERP. And during that time, when I've spoken to prospects and customers, I learned quite a bit about the different strategies people have used to fix their bills of material that really help them to leverage the value of their ERP. And today I'm going to share those strategies with you, whether or not they use my software or our software, or they handle it differently. These tips will give you an idea of what the companies are doing to make sure that the bill of material is accurate and getting the value from the ERP. The webinar is targeted for 30 minutes. And so we'll also leave some time at the end for questions. If you have any questions that come up, feel free to put them in the question and answer session. And then at the end, I will address those questions. Questions make for good conversation, so feel free to put them. We'll leave a few minutes at the end to handle those questions. So let's begin. Okay, first, before we dive into the simple fixes to your bill of material, it's important that we are on the same page, we use the same language in terms of the bills of material, and so that we all know we're all talking about the same kind of thing. First, so let's define what is the bill of material. Bill of material is often abbreviated or with the acronym BOM for bill of material. So you may hear me use it as BOM or bill of material. Those are interchangeable terms. So if I use one or the other, just know that they all mean the same thing. Second is that there are different types of bills of material. So engineering, there's manufacturing, there's a configured bill of material. They're all different kinds of bills of material. I don't want to get too stuck on what are the differences, but let's just say that we're using the bill of material as a general term, and they can refer to, even though they can refer to many different types, we'll focus on a definition that covers all the different types of bills of material. So what I talk about today will cover all the different types of bills of material. So first off, a bill of material is a hierarchical list. It's often can be seen as a recipe or a shopping list for components and materials that are required to build a particular product. I give an example of a recipe, right? So a recipe is very simple. You're going to make a cake. That recipe tells you what are the ingredients, if you will, what are the parts that we need to use to make the end product. Now, a recipe isn't so much hierarchical. But most products, when I talk about hierarchical, I mean that this bill of material has multiple levels. So it's also called indented, right? So it may has many sub-levels, and often is represented graphically with a tree-like structure. So the bill of material often contains manufactured components and purchased. So some of the components, some of the things that make up the bill of material are in fact manufactured by a company, and at the same time, some are purchased. So it's usually a mix of the two. So, and many of the manufactured components contain purchased components or contain raw materials, which are purchased components, for completing the overall product, so that the manufacturer may make some of the end goods that go on a larger product. So in addition to these components and raw materials, a bill of material can have build steps or operations, also called routings. Now, these sometimes are a little different in their meaning, but generally refer to the processes these steps required to complete the actual product. So you take the materials or the components, maybe the purchased parts, and then what does a human need to do to add to those parts to create it? So, and the analogy of a baker, right, or of a cook, it is the process. The steps are, adding the flour, measuring the milk, adding the eggs, anything that you need to do to create for the labor involved with creating that bill of material. So to simplify it all down, a bill of material really is a list, often hierarchical, of all the requirements to build a particular product that is then sold or delivered to an end customer. So whenever we buy a product, whether that be a car or muffins from the store, all of that requires a bill of material to be manufactured, used to manufacture the product, so that when we get it, it's complete. Now, what is important about that bill of material? Well, the bill of material itself is important for lots of reasons, and this graphic is illustrative of why it is so important. As you can see, the largest gear on the left is the bill of material. And it's so important because it's really affecting, driving every aspect of the manufacturing process. So in here, you see this graphic, you see all the different aspects of an ERP. So it's the manufacturing, the purchasing, planning, quality, scheduling, all of those parts of the manufacturing process of an ERP are all driven by the bill. They're all utilize the data that's generated when you create a bill of material, right? So the bill of material, for example, the more accurate it is, the more accurate the costing is. If a bill of material is not correct, right, doesn't have all the components, or you're not tracking all the labor, then the costs cannot be measured. You don't know how much this product actually costs to make. Same goes for the quality. If a part's left off a bill of material, then the quality is reduced, right? And it will not function as designed. So think about if you've ever gotten a package or a product that you need to put together. If it's missing parts, you can't put the assembly, right? You can't build it. So I think about if I buy something from IKEA and I get this list of parts in there that I'm going to use to build, right? It's kind of my bill of material and my instructions for if I'm missing screws or bolts or a piece, I can't complete that. So the quality goes down. So the bill of material is paramount to ensure that you get the quality product. And lastly is talks about scheduling and planning. Without the bill of material needs to represent all the steps and parts to produce that item. So we can't schedule the work to be done. We can't give the lead time. We don't know how long it's going to take when we can ship it to the user if we don't know all the pieces that go into it. How long? So you may have long lead time parts, things that you have to order ahead of time. If you don't know how long those things take to get ordered, if you don't know how long it takes to assemble or to manufacture the pieces, you can't give an accurate estimate on when you deliver. So really every aspect of the business that is the ERP utilizes the bill. So just to sum it up, it is the most foundational structure of every manufacturing company, the bill of material. It is akin to the foundation for your own house, right? So without it, you cannot complete the project. So fix number one. Fix number one is, it may seem obvious, that is, use the ERP bill of material functionality. And you would think, well, that's an obvious thing. Of course, I got the ERP. I'm not going to get the value of the ERP unless I use the bill of material in the ERP. Yes, I agree that would seem obvious. But just to give an example, this week I had a call with an existing CAD Talk customer, and they're implementing the software on another part of their business. And that business, that business unit did not utilize their ERP's bill of material. They had that ERP for quite some time. They've used it, but they had not populated it. They had not filled it out with the product structure. They did not represent their end products with the bills of material. And so the entire conversation was around, we're going to implement CAD talk, but we don't have a bill of material. So this particular customer is going to be upgrading their ERP in February, going live, and they still need to figure out how are they going to use the bill of material because they hadn't been doing it. So number one thing you should do, make sure you're using the software that as it's intended. Make sure that you have the bill of material in the system. Once you have that bill of material in there, then the ERP can do all the pieces that it does. It can manage the bill of material and the inventory. You know how much you have on hand, what you need to order. The ERP can look at the bill of material and handle scheduling, can do costing to figure out how much this product costs. It can ensure that your quality standards are there. That bill of material does is once you're using the ERP for that process, it standardizes the manufacturing process. That bill of material becomes a standard definition for what you're doing. Fix number 2, maintain the bill of material structure. So many complex products, like you see on the right-hand side, have a multi-layered tree-like bill of material, right? So it's fully, we sometimes call it indented bill of material. They have subcomponents and sub-assemblies, so it has a sophisticated structure. Now, I have seen at times where many manufacturers decide not to maintain the structure of the bill of material. Maybe they want to flatten it out for various reasons, or they want to remove some of the structure. And so they're not leveraging the structure and the complexity of the bill. So it's much of the ERP value is lost because you cannot see, you don't have any visibility into the time and effort it takes to make all the sub-assemblies to put the whole project together. In fact, oftentimes when a design engineer is creating a model and creating drawings, those drawings do represent an indented bill. It may not have an indented bill on the drawing itself, may not spell it out, but those drawings do represent multiple sub-assemblies and structures. And so when you modify the bill of material in the ERP and if you flatten it out or you modify it so much, it no longer reflects the design at all and makes it difficult for those guys on the shop floor to understand the relationship between the bill of material in the ERP and their job orders and the bill of material or the drawing itself. So when those types of structures aren't similar, it can create the confusion on the shop floor. So what I've seen people do is that if you have a sub-assembly and that sub-assembly is represented as such on the drawing, it makes sense to keep that ERP bill of material structure. Now, there are some cases where that might not make sense, but a majority of the time, it is more valuable to maintain that structure. And if you think, oh, I want to flatten the bill out, should really ask ourselves why we're trying to achieve that. What are we trying to achieve when we do that? Something else that the levels do, the levels give us more details and make it easier for everyone on the shop floor to understand the steps for building the product. Once you have levels, and the operations, the steps become more obvious about what parts go into what assemblies. The flatter the bill is, then you should get a big pile of materials or a big pile of parts, and now you have to deal with to maybe put multiple things together. It really adds confusion to the shop floor. When the product structure is fully represented, the design engineer and or the shop floor workers can capture more detailed notes at each level, which would help reduce confusion in the manufacturing process. So the more complex the levels, the more data, the more information, and the less confusion you have from top in each phase of the project. So in sum, the structure allows you to reduce confusion on the shop floor. The shop orders and the drawings reflect one another. And you can have detailed notes at each level in terms of the manufacturing process. Number three, include everything that need to build the product. So what I mean by that is include your consumables. Many companies have consumables. It's very common. Consumables might be paint, glue, boxes, lubricants, shrink wrap, pallets, all these types of things. But often they don't represent those items as on the bills of material. They may leave off raw materials or other consumables, leave them off the bill completely. Well, these items, these consumables, they're often used in bulk. You know, paint and glue and lubricants and boxes and maybe shrink wrap. These things are used in bulk, and often people don't want to represent them on the bills of material, either because it's too tedious to enter them, or they think it's not important. The problem being that those consumables, you're using a lot of them, and there are significant costs attached. And when you don't know how much you're using per product, it's hard to get a true idea of the cost of that particular item. Right? So including them on the bill of material also reduces the risks of missing them in the build phase. So what I mean by that is, if they're on the bill of material and the ERP, and they're in the shop orders for the guys on the floor, then what you're seeing is they will be more likely to remember that those pieces get added, that you're not going to miss them, right? So it's really important that you have all the possible things, even consumables. Just because they're not a designed part doesn't mean they shouldn't be on the manufacturing bill of material. So what I would say, first step, start accounting for these consumables. You could ask the design engineer to account for them on his drawing, or you could also manually add them in the bills of material in your ERP. Even if you say, well, I don't know maybe the exact paint, or it's hard to figure those things out, it's better to start somewhere, to start getting that information and capturing that you can improve over time. But right now, if you're not accounting for that at all, it's hard to get the true nature of how much you're spending. And be sure to include all the things that you currently using as consumables, right? That could be screws, rivets, again, paint, primer, even tooling, right? So a lot of times people don't include the tooling involved, or the drill bits, or the other products that may be consumed during that process. And a tremendous amount of cost can go into a product if you're not accounting for those things. Number 4, include routings and track labor. So as we talked about in the bill of material earlier, the bill of material contains not just a list of parts, purchased or manufactured parts, but also contains labor, right? Sometimes I call it operations, or sometimes called the routing, the routing, or the path that the particular product needs to make through the shop. Well, one of the benefits of an ERP bill of material is the ability to define what those routing steps are. What is the process? So using that functionality to define the manufacturing process. That routing tells everyone the steps needed to manufacture the product. In addition to, once you have routing steps, now you have clear directions to the shop floor workers to say, hey, this product or these materials go to this step, and it's easier to keep those pieces together on the shop floor so they're not lost, and they know where they're going next. It provides that direction or that routing through the shop so that everything can be together, and everything can come together at the right workstation, the right place at the right time for the manufacturing process. And also allows you to capture labor. Without a routing step, or without detailed routing steps, it's impossible to capture the true cost of a product. I think about whenever I've had work done on my house, I know that if I've done my own work or if I have work done, the labor for a particular project is at least 50% of the cost of the entire good or the entire end product. So if you're not capturing all the labor, if you're not tracking how much time people spend working on a particular piece of subassembly or a particular piece of product, then it's really impossible to know how long it takes to manufacture that. When the operation is defined, right, the shop floor workers can track their time, they know how long it takes. And once you have that accurate routing, right, and you can track your labor and the run times and you have all of that, you can also have a better idea of how long it's going to take, what the lead time is, how accurate your lead time is to deliver the product. Without that, it's based on historical experiences or really guesses or what people have typically think it's going to take. And then without knowing for sure, without having some idea, you cannot deliver that product on time. You can't get to the market with any consistency because you don't know how long it's going to take. So without having those routings, it's really very difficult to schedule a delivery date. Now, what I've seen people do in implementations is that oftentimes they will say, "Wow, we have a simple product, we don't need routings," or they'll put everything under one generic routing. They won't track any labor. What I found people do the most successful is that they really utilize the different routing steps and capture them in the labor. Some of the most successful implementations, some of the most successful customers I've seen have even used the ERP to capture the engineering effort to design a particular product. So that really gives you a better sense of how much time and money is being spent on this particular product. And fix number 5, what I would say is the sort of most advanced thing you can do, which would be to base the bill of material on your engineering data. So since the advent of 3D CAD, which has been around quite some time now, the 3D CAD has a tremendous amount of data already built in. So when the design engineer is creating his or her model, creating sub-assemblies, creating cut lists, really designing that product, there's a tremendous amount of data in there that can be used to figure out a lot of this information that I'm recommending people use in their ERP, right? There's lots of ways to automatically determine routings or to leverage that information to give you what you need. So don't just waste we can squeeze all the value out of that design to help inform us how to create that bill of material in the ERP. So for one example, say you can use that engineering data to determine routing steps to build a particular subassembly or part. And I've done this many a times with rules with CAD Talk. And it's not required that you have a software like CAD Talk to do that, but you can use that information, like our point number 2, you can create rules from that engineering data to calculate raw material, to calculate runtime, setup times. So it's even before people who haven't used CAD Talk can still use that data from their model to say, okay, is this particular item, is it a sheet metal good? If it's a sheet metal good, it's made from sheet metal, then I know it goes to the laser or the plasma. Maybe it goes to the bend shop. If it's extruded material or it's channel or pipe, maybe it goes to the saw. These rule-based systems, even if they're not automated, if they're manual, can help drive efficiencies and accuracies into the bill of material. Anytime you're basing your decisions on data and especially design data, and you have a rule-based system, that system can be improved upon, and you can get better value and better information from the ERP. So what I would say is if you're using the bill of material, you've done all the, if you have routings and you've done all that, have you applied a rules-based system? Are you determining the information that you're entering in the ERP based upon some kind of rule? Or are you just using historical information like, well, or someone's experience? How are you determining? How do you derive efficiencies and consistency? You can do that by creating that rule-based system. And lastly, how do you keep the bills of material up to date in the ERP? Well, the best way that I've seen that done, that we do it with CAD Talk, and I've seen that's done with even manual, is create an auditing system so that the ERP bill of material is updated once the CAD revision has been updated. So if you're tracking, most engineers are tracking revisions in the bill of material, or excuse me, in the drawings or in the designs in CAD. Utilize those revisions to trigger updates to the bill of material in the ERP, right? So even if it's manual and you go through engineering change, the design engineer should update the manufacturing engineer, or use that as a trigger, and then use the rules that they've created, and then make the changes in the ERP with the new data. Right? Now, if you want to think about how I could do all that, but that would take quite a bit of effort. Then we could talk about how CAD Talk could be a good benefit or good use of automating those steps. But even if you're not just ready to say, I'm going to automate that today, it's still good to think about, how do I get this information in there? Okay. And lastly, what does this matter? Why does it matter? Why do I care about the costs of the bill of material? Why do I care about the costs of an accurate BOM? Or why do I care about getting the value out of the ERP? Well, ERP implementations and software often cost hundreds of thousands of dollars. And the point of the ERP, the value of that is so you get better information, better costing, better scheduling, planning. You can deliver to your customer faster, your lead times. Well, what's the effect of a mistake on a bill of material? So I have this kind of story, a $1 mistake, right? It's a cautionary tale. So a lot of research points that one mistake, that on a $1 mistake in engineering, if it goes from an engineering mistake to the manufacturing, right, and that handoff, that could end up to be a $10 mistake on the shop floor due to wasted material or reworks or confusion or just lost labor. Now, what happens if that $1 mistake now becomes a $10 mistake in the shop floor? Let's say it gets past the shop floor and then gets all the way to the customer. Well, now you're talking about another $100 mistake because now the customer gets the product, it doesn't work, they have to call in. You have to send them something new, or worse, you got to send a technician out to fix the product. You got to ship the product back. You got to pay for that. So a small mistake has a tenfold increase in expenses at each stage. So not only is it costing the business even more money, you're really not getting any of the value out of that ERP, right? It's similar to building a house on a foundation that's crumbling, right? You have to have that strong base before you can really get the benefits of the rest of the system. So if you're doing some of those things that I talked about today, you're utilizing those, and you want to consider, like, am I doing the right things, right? Feel free to schedule a call with me, and I can give you a free BOM report card to kind of tell you how you're doing against other people I've seen, what works best. One of the things I have to say is I'm a former Latin teacher, so I'm quite skilled at understanding complex subjects and coming up with ways to explain them and get to where you need to be. So I really enjoy having those conversations. So feel free to schedule with me and we can review the health of your bill of material. Now, if you can kind of find us at our website at cadtalk.com, and you can schedule a call with me directly at that link below, cadtalk.com/demo. If now we have a few minutes for Q&A, questions and answers. If you have any questions or want to know more about some of the things I talked about or experiences I've had implementing customers, feel free to ask now. We can take those questions. Okay, so no questions yet. So just give a little bit more, a few more seconds to see if anybody has some additional questions. No? All right, doesn't look like we have any questions today. I thank you everybody for joining. I appreciate the opportunity, and you guys have a wonderful day, and happy holidays and happy new year. Thank you very much.